Well, good afternoon, everyone, and thank you for coming to this final talk at the end of the day. I'm quite impressed there are so many people here and not at the pub round the corner. Before I start, I should say that I'm just coming down with a slight throat bug. So I'll be taking judicious amounts of water, and hopefully I'll get to the end of the talk in one piece. So it is a long way to come to talk about Keystone implementations, but what a lovely city to be in. Who am I and where have I come from? I work for the Catalyst Cloud with a lovely group of people in the operations team. In case anyone is not familiar with it, the Catalyst Cloud is an OpenStack-based public cloud provider in New Zealand. Now, I'm sure there's at least one person in the audience who's wondering where on earth New Zealand actually is, and believe me, there have been some strange ideas about where it could be. So it's about 13 hours flight to the southwest, well off the coast of Australia. And given the distance from the major continents, it's always a privilege when I'm able to make one of these conferences. It is partly due to this remoteness, however, that led to Peter Jackson's reimagining of Middle-earth in New Zealand not so long ago. This is Aoraki Mount Cook with Lake Pukaki in the foreground, used in the filming of The Hobbit. Although I gather they actually used a CGI version of the mountain in the end and kept the lake at the bottom. So anyway, we currently have 3 geographically distributed regions. We started R&D during Folsom, targeting Grizzly for release, but actually going live with Havana. Since then, over a series of inline upgrades, we have a mixture of Liberty to Pike, with 1 or 2 ancient bits, such as Ceilometer, that are still Kilo. Overall, we use Kilo for block storage and glance images, and Swift for object storage, QEMU KVM on our hypervisors. And yes, basically everything is open source. We use white box switches wherever we can. So why give this talk? After all, Keystone has been around for a very long time. I mean, you just deploy it and it works. But I come from an operations background, and thus this talk is aimed very squarely at other operators. Hopefully there are some in the audience that have to juggle upgrades, hardware life cycles, and the chaos of the public internet without impacting service level agreements. In a sense, what follows is nothing new. Reading through many of the best practice guides might lead you to exactly the same configuration, if you can find all of the parts of the jigsaw. The way that public clouds are deployed in production is often subtly different from the way that one might otherwise deploy something for a small test environment, obviously. And those subtle details are often only discussed over a beer quietly between other operators. So I think the wider dissemination of these things is very good. Anyway, for some of you it may be old news, and you may have already implemented something very similar to what I'm about to present. In fact, I know that at least one major public provider has reached the same conclusions. For those of you, congratulations. Anyway, I will basically cover the process that we went through to reach what we believe is as good as we can get in terms of a resilient multi-region Keystone. So some caveats. I won't cover the details of Keystone configuration. There are a lot of guides around covering that. And I should also say that I'll only cover SQL-backed deployments. A few other caveats based on the focus on edge computing at the moment. I'll say that we have no desire to restrict which regions users use, other than giving them some subtle defaults, which drives a lot of people in the direction we want. In other words, we're not talking about edge computing. These are full standard regions with proper connectivity between them in proper data centers. Anyway, the core purpose is to help any other cloud operator that might be around and may be experiencing multi-region-itis and perhaps save them some time. Right. I think that's, yeah. So if we can cast our minds back a few years, the Catalyst Cloud had, like everyone does at the start, just one region and all was well. Compute, storage, network, plus all of the sundry services such as image, dashboard, billing, and so on. Plus identity, which links them all. But soon enough, someone wants a second region, fairly necessary for DR purposes, so who could blame them? Well, that's fine. But before you know it, everything is racked and built, and the additional endpoints are added to the service catalog, and authentication and access control is kept centralized in the first primary region. This means that regions could be selected from the drop-down box in Horizon, or just by passing the appropriate values to the APIs to the global identity endpoint. It was simple and least surprising for customers. From the point of view of Keystone, Failover, however, in a DR scenario was simply an old school import from the last dump. But before you know it, a third region is being built. Obviously, a nice side effect is that now that geo-replicated storage is actually quite resilient. But with the same architecture as before, Keystone is still operating out of the primary region. Failover is manual, straightforward, but manual. So as of mid-last year, we had 3 data centers spread along the length of the North Island. It's only about 500 Ks, or 11 milliseconds. But all it takes is a careless contractor, and this was in Auckland a wee while ago, or an earthquake, and this is Wellington a wee while ago as well. And your redundancy really will be tested. None of this is anything unusual. It's just life in the real world. Of course, it doesn't have to be that serious. Even just a minor blip here and there, and all of a sudden you have customers on the phone wondering what's going on. They don't know or even care that everything has to authenticate, and those requests are being amplified throughout all the regions and services. Everything on the control plane has to authenticate. So, hypothetically, what would happen if Keystone should fail? If it's a private cloud, to be honest, it probably doesn't matter too much. The control plane will be degraded, to put it nicely, and you might have to tell everyone that there's a change freeze until it's been sorted out. However, with a public cloud, it's a bit different. The above still applies, but it is seen differently by external customers. So all API requests would fail. The dashboard, which, as you know, is all just a front end, though a very pretty front end, you must admit, to those APIs, would no longer be able to authenticate either. No plumbing of new instances, and no removal of instances. And crucially, in all likelihood, there would be no ability to measure or charge for resources, even if by some miracle SLAs were actually still being met. The data plane, with running compute instances and so on, would carry on as before, but no state change would be possible. If they crashed, needed console access, different security groups, storage added or removed, well, you're out of luck. And obviously, no orchestration. So being on the open market, customers would soon pack their bags and take their business elsewhere. So back then, our Keystone environment was pretty standard. Uwhisky and Nginx on the API nodes, receiving calls from the front-end proxies and passing them off to memcached before resorting to the Galera cluster at the back. Keystone itself was deployed via gift-wrapped Python virtual environments. And yes, back then our Keystone was Kilo with UID tokens. More on that later. So this is just a simplified version or schematic of the layout. There's nothing unusual here. It's pretty standard. Just the internet's a front-end proxy layer, API layer, memcached layer, internal proxy layer, and then the Galera cluster layer at the bottom. Now, what do we actually want from Keystone, not what we had? Well, loss of a region should not affect the operation of any other region. The major partition must continue as before, and the minor partition may be able to operate in read-only mode briefly, depending on what state it's in. A user should be able to use any region that they have sufficient quota for, and authorization, authentication, and access should just work. The service should also, the service being Keystone, should also be able to self-heal in all but the most dire of situations. To sum up, what we were really after was for us to be able to basically lose one entire region and the other 2 regions should not notice. The failover should be transparent. So how can we do this? What are the options? Now, the first problem can really be rephrased as how do we make the Keystone database highly available? The rest is quite a bit simpler. The API daemons can live pretty much anywhere as long as there's minimal latency between them and the services they provide authentication to. So we can either have multiple Keystones, one for each region, or a single Keystone. So multiple ones, could also be for anything, for one AZ or whatever, it doesn't really matter. Anyway, the first option actually comes up quite often in discussion, but in my view, for a public cloud, it is probably more trouble than it's worth. You either have to accept that your regions are completely separate, as are their users, projects, else find some way of syncing the parts that matter between them without bringing everything to a grinding halt. Both are quite difficult to do properly, and you're still left with the DR problem for each region. So in effect, you've made the problem 3 or more times harder. It's possible that having multiple keystones would make sense in a proper edge case, but I guess we'll see what the future brings. The second option is well tested, and it is what everyone has by default. It comes with a caveat that you actually need to want to have all of your users and their projects available in each location, regardless of whether they consume the resources there or not. It also assumes that users will have the same rights, regardless of region. You can still limit those resources via quotas, of course, if you wish. So looking at the first option with multiple keystones, we did look at federation, but it essentially only solves a slightly different problem. We could have maintained separate providers in each region and federated between them. However, by default, we would gain nothing in terms of DR recovery across regions. In other words, if we lost some part of Keystone in one region, by default, another region would not simply take over without anyone noticing. It's possible that this is useful or even necessary in the EU with the recent and impending changes in the legal framework that may well require it. But for us, there's little to gain. Now, in terms of a single unitary Keystone database that is just always there, one of the first options that comes to mind is, came to my mind was CockroachDB. Honestly, it's a technology we wanted to love and wanted to use, but it is not quite ready for Keystone, at least not in production. There's a long thread in the archives discussing this, if anyone's curious. So, master-slave replication between data centers. In other words, just a slightly more efficient version of the process we already have. The replication would have been asynchronous, and that's painful. There would have been a lot of testing of the cutover. Everyone would have dreaded it, and frankly, there's no need for that sort of thing these days. Circular replication, or essentially an older version of multi-master. Well known to be prone to problems. It's still asynchronous. We did not want that either. Galera site-to-site replication. In other words, multiple Galera clusters linked via one or more replication channels. This was probably the best contender, and perhaps would be worthwhile with an order of magnitude more regions, all integrated with the same keystone, but not at this scale. So what did we decide on? A single inter-region Galera cluster containing just one Keystone database, with nodes in all regions, providing data for all regions. If you remove the CRUFT, the backend database for Keystone is actually pretty small. But as we have synchronous replication, the locks, inserts, and updates must be negligible, and that can really only be done with Fernet tokens, as we'll see soon. We also settled on distinct authentication endpoints in each region, which, as they back onto the same cluster, are essentially identical. And this has quite a few follow-on benefits. The dashboard remains as before and can authenticate against any of the configured endpoints, with both region and project selectable as normal. For API access, you can just pass the appropriate region variable to any authentication endpoint. And yes, I mean any authentication endpoint. They're all equivalent, the only difference being the name that they advertise themselves as. A token can be fetched from one region and be valid for the intended scope in another region. So, as all endpoints are equivalent, another can take over if the others are down for any reason. And this is quite useful. It's largely a matter of front-end and back-end proxy configuration. It's important to point out that the remaining API services, Nova, Neutron, and so on, still obviously have their region local DB clusters as before. And this is where the quota limits, private Nova flavors, and so on are kept region-specific. So the implementation. The first thing we had to do was upgrade Keystone. Kilo is ancient, you must admit. At this stage, we made a decision to only go as far as Mitaka due to the deprecation of the V2 APIs and a contractual obligation to continue offering those at least until later this year. This was straightforward and just a matter of very careful checking of over 100 release notes. So anyway, we still have Keystone deployed as before, but with multiple nodes per region. However, it is now deployed into all regions. Incoming requests are handed out by the current master of the front-end external HA proxy nodes. We did a lot of testing to try and find the optimum multi-threaded UISCI configuration, but quite frankly, all that matters is the number of available cores together with suitable memory for each to run on. We also took this opportunity to include a local patch to enable the optional use of multi-factor auth. This was the result of some excellent work done by Adrian Terjak and Amelia Caldwell. Some of you may be thinking that this is already available, it's already in master, so why are we going to the trouble of a custom patch? Well, the main issue is that while there is a TOTP plugin for Keystone, there isn't true multi-factor auth. And what we wanted was the standard scenario where you would allow users to enforce the requirement themselves on their account that TOTP plus the password must be used for all API and dashboard requests. It's got to be optional. As a public cloud provider, we can't force our customers onto it. It must be their own choice. Sure, it's a very good choice, but it's their choice. Anyway, as with anything, or most things that we do, it's open source and the code's on GitHub, and we're looking to push that upstream. The next step was switching the token format. So if you've been watching token issues late one spring evening, and quite frankly, who doesn't want to sit there with a nice glass of wine and watch token issues, you'd have seen the following. So do you see it? Yeah. Subtle change. All that's required is a one-line change in keystone.conf to switch from UUID to Fernet tokens. It also invalidates all existing tokens. So with one step, many, many gigabytes of tokens vanished into the night as the token table was truncated for the last time. Obviously, if you're running a recent version of Keystone, you already have Fernet tokens. If not, then I highly recommend switching formats and updating. There's no scale on the left-hand one, but it says, we basically went from about 14 gigs down to about 200 megabytes for the Keystone database. And the right-hand plot is of inserts before and after switching to Fernets. So there's no longer inserts for the tokens. Anyway, Fernet tokens. Now the important part is that the ID is actually an encrypted message-packed payload, and nothing is kept in the DB. This is all that there is. And it's actually fascinating to drill down into one of these tokens and see what's packed inside. So you can just run curl against one of the endpoints and pipe the result through Python's JSON tool. And what you'll see is this, maybe not readable, but it contains the endpoints for all regions, URLs, roles, domain, token issue and expiry, and so on, all contained within what appears to just be a strangely long token ID. The next step was creating an inter-region Galera cluster with at least 3 nodes in each region and an odd number in total. There are a lot of configurations that are available, but the 2 lines that are highly useful here are dirty reads, so that if a node becomes part of a minor partition, you can still read from that part if you wish. Once it rejoins and is accepted by the primary partition, it will catch up and all is well. Of course, this also depends on how you configure your health checks and how you want the region to behave. If it has come out of the rest of the world, hopefully for a limited time only. For our case, we decided that it was best to allow authentication to continue anyway, just for that brief read-only mode. Sync weight is debatable. We found it effective to have it set to 1 and always sync for read, select, and show, as each active node always has at least one path to another node. Others that are nice to have are setting the slave threads to the number of cores and keeping the maximum connections very high. The last thing you want is to hit that without realizing it. Inter-region connectivity is simple enough. You just need to be very careful about what goes across, so lots of firewalling. And then we did a lot of testing, the thrashing of the inter-region cluster. This was largely a matter of running scripts such as the following to see if we had any unexpected locking or other bottlenecks. It's worth mentioning cache configuration for Keystone. It is pretty essential. Your Keystone and ours would have probably melted without it. We were certainly hitting performance issues until we activated that. Anyway, as you can see, 60 minutes is overkill, at least in our scenario. This is a plot of the hit ratio on one of the cache nodes for the first hour after a restart. 10 minutes would have been fine. Most of the customers don't appear to want or need longer caching than that. So the final cutover. This is the point where the changes become quite serious and a little bit delicate. Until now, despite the changes above, Keystone was still effectively just in one region. Everything was pointing to the old endpoint, even though the nodes were there. So now the internal proxies and external proxies could be updated. And the endpoints were now and then late one night, we cut over to the new cluster with just a few seconds of downtime. Endpoints were now active, just unused. One by one, each control plane service was then redirected to the new endpoint, to the local endpoint. Endpoints were then added to the service catalog as returned by the APIs. At the risk of repeating myself, all of these endpoints are effectively identical, just advertising themselves differently. But they all can return the same data. And we also set all of the endpoints to be unversioned, i.e. leaving off the v2 or v3 suffix that is very historical now. So any client can specify the desired version, at least until we take away v2. Now, the fact that each public endpoint can return the same data means that we can add all of the remote endpoints to the set of local external proxy servers. And this means in the event of a complete failure of Keystone in one region, another region will take over. And this can happen quite transparently, as you'll soon see. Right. So this is another rather difficult to read schematic of how Keystone looks today across the three regions. In each region, there are the redundant external proxies that receive requests to the endpoints advertised in the service catalog. These go through the same API, memcache, and internal proxy layers before reaching the Keystone database. The key difference is that the Keystone database is the same everywhere, and each node on that cluster is in a full mesh with the rest of the cluster. Each part of the cluster knows how many nodes should be present, and if it realizes it's part of a minor partition, it becomes read-only on its own. Meanwhile, the rest of the cluster carries on as before. If all nodes in a region are down, then any other region can answer requests on its behalf until it begins passing health checks again. So, demo time. I should say at the outset that this is not a live demo. It was recorded last week. I am too risk-averse to trigger this sort of thing from the other side of the world. But it is a full production failover of Keystone in one region. It's also about as interesting as watching paint dry, so I apologise that it's not presented in a more Hollywoodish style with blinking lights and pretty graphs and things. But if you watch carefully, you will see that one by one, each API node vanishes in what was previously the primary region, together with all of the Glera nodes that they back onto. At the bottom are three watches that are set up issuing token or fetching tokens from the public endpoint for Keystone in all three regions. Just to illustrate that as far as customers are concerned, everything was fine. So just to highlight those two bits, on the far left, the status of the API nodes, and on the far right is the traffic going through them. So it's probably running now. So it takes a few minutes to run. So soon we'll see the health checks on the first, second, and then third API node just fail, and then all of a sudden another region, which currently has got zero traffic going through it, will take over. Yeah, so it's the first one down. Second one down. Third one down, and already traffic started going to the Hamilton region. So soon that'll be reversed. The API nodes in the Wellington region will come back online, and traffic will stop going to Hamilton. At this stage, however, the entire back end is dead, deliberately stopped. But it would make no difference if that was completely deleted or truncated, unset, whatever you wish. So I'll just wait for that to come back. That's one of them. So the status of the front end is still open, of course. Right, there goes the first one. So then the others come back. But anyway, the point is that traffic is no longer going to the remote region. So where to from here? The main thing we'd like to add is a generic global endpoint via Anycast or even just Fastly. We, and by we I mean Adrian Turchak, are working with the Keystone team to get MFA into a usable form in master. And our current Keystone is still very old. We have Pike currently in testing, but the place we want to be is one release behind master. We'll have to keep the V2 APIs until later this year, so that is being held off somewhat. In summary, we recommend for public providers such as ourselves, Keystone with a single geographically distributed Galera cluster for all regions, Fernet tokens with caching, and obviously redundant routes between all nodes. For the proxies, other regions must be present as backup servers and optionally made available via an external provider to make available a single generic endpoint. There's also the option of using DNS round robin and master backup tricks with the likes of KeepAliveD. If that is, you haven't fainted at the thought of using KeepAliveD in production. I wouldn't blame you either way. Anyway, thank you for being a lovely audience. So any questions? Yeah.
I got one. Imagine now you have a region that's not inside New Zealand, but maybe somewhere in Asia, and you have 100 milliseconds. Would that approach still work?
I think it would. I mean, the amount of traffic that goes over this cluster is minimal. I was checking it today, and it's about 22 kilobits per second per node. So it's once, I mean, it really is just people changing passwords and adding roles and users and projects. So it's not much traffic at all. It'd be interesting to try. I doubt it would matter to Asia. Further afield, maybe it would matter.
Okay. Yeah. Was that different when you were still using UID tokens?
Oh, we could not do it with UID.
Okay.
No.
Okay. I get it. Thanks.
So do all the users have the same privileges in all the regions, or did you solve that? Or
they do, and we made no attempt to solve it. For us, that is the desired scenario. Yeah.
Okay.
Yep.
You mentioned briefly at the end the desire to update or upgrade Keystone. Have you figured out a way to do that in a rolling fashion in this architecture, or do you just have to take it down in all three sites?
There would be a minor blip. Basically, what we would do is take all of them down late at a very quiet time, all but one, and then upgrade that, and then bring them all back online one by one as they're upgraded. We can do Mitaka to Pike in one sweep. That's been tested. That's fine. It's just a matter of checking more release notes. And, yeah.
The replication usually goes with a delay. Have you faced any issues which has roots in it? I mean, for instance, you've created a user, and the proxy was directing you to one API, which goes to local Keystone database, and the next request, for instance, for getting a token, goes for another Keystone. Have you faced situations when these requests arise before the user record in database has been replicated to this local database?
No, we haven't yet.
The replication is synchronous, isn't it?
It is synchronous, yes. So,
Come back until it's been replicated.
yeah.
Oh, yeah. Okay.
I mean, it does. I mean, there is a tiny lock at that point because it's synchronous. But no, we have not noticed anything yet. Yeah.
Thanks.
Yep.
Do you have any estimates to how many regions this would scale? Like Galera cluster across like 10, 12, whatever nodes. Does that scale that far?
I would not want to put a number on it, but waving a finger in the air, I'd guess it would easily handle. I mean, I would be interested in trying anything up or less than 20, I suppose, just because at least with us the churn rate of user data is so low. Maybe in a different environment it might be different, but yeah.
The other thing to remember about this architecture is you don't, if say you go beyond 3 sites, you don't necessarily have to have a Keystone, database node in every single site.
Yes. So for us, we were killing several birds with one stone. Yeah, exactly. So we've got what we want. Yeah. Well, if no other questions, thank you all, and I'm going to go and have a beer. So, yeah.